Welcome to another one of Mercy's Things to Do, presented by DiscountLowVoltage.com. Hey, what's going on, guys? We have a fiber optic tester here, and we're going to measure dB loss of a fiber link. I'm going to keep it real simple for you because it is. We don't have to get sucked into all the math and all the black magic of fiber optic cable. So let's get to it. Now, what we're looking for with dB loss is set in stone by EIA TIA 568. For multimode loss, they don't want more than 3 dB per kilometer at the 850 wave source. If you're going to do the 1300, it's no more than 1 dB of loss per kilometer also. So what we're going to need to figure that out is a light source, a power meter, and then we can find out the dB loss of our fiber link. Okay, so we have our optical power meter and we have our light source that does multimode, the 850 and 1300 that we're looking for, but we're just going to stick to the 850. And you're also going to need 2 jumpers. You're going to need a transmit jumper and a receive jumper. Now your transmit jumper, it must be wrapped with a fiber optic mandrel. Okay, before we check our fiber link, we want to make sure that the equipment here by Al is working properly. So what we're going to do is we're going to connect the power meter and light source together with a straight patch jumper. And let's turn this bad boy on over here. You're going to notice the 850 pop up there. Now let's turn the power on the power meter. Okay, you notice that we have it set at 850 as well. We just want to make sure that our patch jumper here that we're going to use as the receive jumper is at an acceptable power level. So what we're looking for is 62.5 is between -19 to -21. If you got a 50 micron jumper, we're looking for -22 to -24 in that range. Anything else, you got to replace the jumper. You probably got a bad one there. Toss that out, get another one. Now that we know the equipment's working properly, let's go ahead and remove the straight patch jumper from both sides. Okay, so we're going to check out the transmit jumper now. We're going to make sure it's within that level that we're looking for. So let's go ahead and turn on our light source here. We're going to repeat the same process we just had. And let's turn on the power meter here. Okay, on that jumper we have a reading of -20, 55. So for 62.5, it's within the range. That jumper is good to go for us. Now don't take off your transmit jumper. What we're going to do right now is we're going to set a reference, and it's commonly known and referred to as zeroing. Okay, let's go ahead and zero out the test equipment here. There you go. That easy. Now the Zoom 2 display should change to show readings in dB, and the power reading should be approximately 0.00 dB. Now this means that the meter and light source have been successfully zeroed at the 850 wavelength we're looking for. Now we can disconnect our patch jumper from the Zoom 2. Don't forget, do not disconnect the mandrel wrap patch jumper, the transmit jumper, from the Dual Al 850 until all the fibers in our link have been tested. So just leave that jumper right there. So for demonstration purposes, we got a multi-mode jumper. It's kind of a long one, I don't know, maybe 50 feet. So this is what we're going to test. This is going to be our fiber link. But of course, if you're going to check dB loss at your job site, at your facility, it's probably not going to be a jumper. It's probably going to be maybe an indoor, maybe an outdoor burial cable from building to building. Or maybe it is a loose tube type of fiber. Or it could also be maybe an interlocking armor, or just your standard indoor-outdoor type of construction, going from outdoor to indoor, past 50 feet for them fire codes, that sort of thing. Whatever your link is, we're checking dB loss. So just, picture whatever you have at the job site as whatever cable you have there. And, yeah, now let's check dB loss. Okay, so I was only going to use the fiber jumper, but I thought, man, let me get a couple of boxes, some panels, so you guys can visualize it a little bit better. So now you're going to want to connect both units with their appropriate test cables to the opposite ends of your fiber link that you're testing. Record the current reading for the current fiber under test. Then you can disconnect the patch cables from both ends of the patch panel and move to the next port on your panel. So that was pretty cool, and it's pretty easy to do. I know you guys can do it. I just showed you how. Your power meter and light source, this is sold as a kit. The manufacturer is out. There should be a link, if you're viewing us on YouTube, right up there, where you can click on it. It'll take you straight to our page. You can purchase it. It's $350, made in America. We've been selling this brand for a long time. It's really pretty good. You should have it for a long time. Now, if you're already on our website, then buy something, and thank you.